Okay, to graph the quadratic function y equals 3 times quantity x plus 5 squared minus 8, the first thing we need to do is we need to find the vertex, because this is a quadratic function. The most important point to find is the vertex, whether it's in vertex form or standard form. Now, the fact that it's in vertex form, the whole reason it's called vertex form is that you should be able to look at and identify the vertex. Now, you need to know that the vertex form of a quadratic function is y equals a times the quantity x minus h squared plus k. Okay, in that form, the vertex is always going to be h comma k. However, when we look at our example, we have x plus 5, not minus. Remember, if we want to change addition to subtraction, we need to change this addition to subtraction of a negative. Here it should be plus k. Well, we're going to change this to plus a negative. So as you look here, y equals 3 times the quantity x plus 5 squared minus 8 can also be written as y equals 3 times the quantity x minus a negative 5 squared plus a negative 8, which would allow us to see that h is negative 5 and k is negative 8. So for this particular function, the vertex is negative 5, negative 8. Now again, if you want to look at this thing plus 5, you just change the sign and then keep the sign of what's on the outside, that's fine. But just keep in mind this is y, given the vertex function and how it's defined. Now that we've found the vertex, that's the most important point. And to find other points to give us a more accurate sketch of this graph, we can simply take this vertex, okay, plug it into our t-chart here, and then we can just pick values of x on each side. Keeping in mind that this is symmetric, we would like to pick values of x that are equidistant from the x-coordinate of the vertex, so you could pick values like negative 4, negative 6. And you just plug them into the original function. Now, keep in mind, this is how you should go about graphing any function that you're unfamiliar with. In this case, we definitely have a place to start because we have the vertex, and if we plug negative 4 in here for x, negative 4 plus 5 is 1. 1 squared is 1. 1 times 3 is 3. 3 minus 8 is negative 5. I actually plugged that in here for negative 6, but negative 6 should be the same, and negative 6 plus 5 is negative 1. But a negative 1 squared is positive 1 times 3 is 3. 3 minus 8 is negative 5. If you'd like to find the y-intercept, you can just plug in 0 for x. That's 5 units away from the x-coordinate of the vertex, so on the opposite side we will plug in negative 10. If we plug in 0, 0 plus 5 is 5. 5 squared is 25. 25 times 3 is 75. 75 minus 8 is 67. That would be a really large graph to sketch, but those are 5 points that are on this parabolic curve, and we could use those points or any others to graph. And that will give us a very good sketch of this curve. Now, to double check this, I'm going to graph this using the math function here. And then I'm going to talk about another way of finding these points using A. Okay, now this is going to be kind of a brief description of A, and I'm not sure that you're necessarily going to pick up on exactly how this works from this description, but anything you can pick up will be great, and it will help you when we explain it more in detail tomorrow. Now, as we pointed out in class, the quadratic functions are very similar to alg functions, but obviously not this, because value functions are made up of two linear functions with opposite slope that meet at the vertex. Here we're not dealing with linear functions. However, just as A affects the slope or how steep each side of the graph of the absolute value function is, the A affects the quadratic function in the same way. Now if we take a look at the table, I'm going to try to match this up with what we have. At negative 10 it's 67, which is good. At negative 6 it's negative 5. At negative 5 it's negative 8. At negative 4 it's negative 5. And at 0 it's 67. Now if you take a look at this vertex here, I'm going to change back here. If we take a look at this vertex, when we moved 1 unit to the left and 1 unit to the right, you can see that there was an increase of 3 units. That 3 units is directly tied to this. Now, if this 3 wasn't here, It would simply be as we moved 1 unit to the left and 1 unit to the right, it would increase the value of y by 1 unit. However, this is not linear, so as we increase or move 2 units to the left or 2 units to the right, it's not going to then increase by 2 units from the original or the y value, the vertex. It's going to increase by 2 squared. It would increase by 4. Now, that same rule applies here, but because we have a 3 here, after we square that 2 and get 4, we have to multiply it by 3 and get 12. And so this value of negative 8 is going to increase by positive 12. So what you can see here is a vertex of negative 5, negative 8. We move 1 to the left, 1 to the right, increases by 3 units. That's because 1 squared is 1, 1 times 3 is 3. Now, as we move 2 units to the left and 2 units to the right, we went from negative 8 to positive 4. That's 12 units away. That 12 came from 2 squared is 4. 4 times 3 is 12. To do one more, as we move 3 units to the left and 3 units to the right, we're now at 19. Okay, compared to negative 8 is 27 units away. And if you think about 3 squared is 9. 9 times 3 is 27. How we can use A in vertex form to find those additional points as well to help us more accurately sketch the quadratic function. And that's several ways on how to graph this particular function. You can use these same properties to graph 2, 4, 6, and 8. I believe this was 10. So